Assalamualaikum, good afternoon. Today I am going to be presenting about our automatic irrigation system using IoT elements with added Arduino microcontrollers. So this is our project presentation from group MP3-2. So with me, you have yours truly, the group leader, Ahmad Dawish bin Muhammad Zuraimi. I am going to be presenting to you all about the introduction about our project and what is it about, our objectives and the scopes. So with me today, I have Amma Shuaib. Amma, would you please introduce yourself?
My name is Ahmad bin Shoaib.
All right, thank you, Amma. And we have our other member is a very smart member as well. We have Ashwin. Would you like to introduce yourself, please?
Hi fellows, my name is Ashwin Kumar Laki Saravanan.
All right, thank you, my fellow members. So as I said before, I am going to be talking about the basics of our presentation and the demo about our project. So Ashwin, would you move on to the next slide, please? Okay, so this is our introduction for our project. So everything nowadays is mainly IoT based, like Bluetooth, Wi-Fi. It's all remote control. We don't use physical controllers anymore. When we're playing a game, we don't use physical controllers anymore. We always use like remote controllers nowadays. So we want to bring that concept, remote controllers, to the agriculture sector, the industry of the agriculture. So what we're doing is basically using the Arduino microcontroller or microprocessor to control the irrigation system. Usually you have like a manual irrigation system. Usually you have to pull, say you have a big tank and then you have to pull a valve and then that sends all the water out. Then when you're done, you have to close it. Now you no need more for that. So with our system that we have designed, from inspiration and some references we took from online and some engineers online as well. So we developed a automatic irrigation system, and it's a smart automatic irrigation system. Excuse me. So this system will monitor your moisture level and will make sure that you get the required amount of water. You won't underwater and you won't overwater. So you get the efficient and the uttermost complete amount of water your plants need. So basically, your plants will continue to be healthy and it will, of course, enhance the crop yield and productivity since your plant is getting the required amount of water, no more excess water, no more excess fertilizer or anything. So this is what our system is about. So this is what our project's concept mean about. It's just to improve and to make agriculture or farming, gardening more efficient for the daily consumer since we are all busy with our lives. So now, next, I will pass on to Ashwin. He will explain to you all the components about this project. So Ashwin, would you please?
Thank you, Ahmad Dawish. So these are the components that we use for our mini project. The first is Arduino Uno Rev4 board. So this Arduino R4 receives real-time data from soil moisture sensor, which continuously monitor the moisture level in the soil. Arduino Uno Rev 3 board. So this Arduino will display the moisture readings and pump status on a digital LCD 16x2 screen, and it will process the soil moisture data to be displayed and stored in a remote cloud with the help of the Arduino R4 board. Next, we have capacitive soil moisture sensor module. So it is responsible to detecting the moisture level in the soil and sending the data to Arduino for further processing using the coding. Next, we have resistive soil moisture sensor module. This sensor consists of two conductive probes that are inserted into the soil. When water is present, it decreases the resistance between the probes, which the sensor converts into an analog voltage. It also can assist in processing the moisture level data, pump status, and exporting it to an output to be displayed on a digital LCD 16x2 screen. Next, we have 5-volt ray module. When the soil moisture sensor detects the soil is dry, the Arduino sends a digital high or low signal to the relay module. This signal activates the relay, which closes to an internal circuit, allowing current to flow to the water pump or valve. The relay remains on, energized while watering is required. Once the moisture level reaches the desired threshold, the Arduino turns off the relay, stopping the pump. Next, we have 5-volt DC water pump. It is responsible for physically delivering water to the soil when the moisture levels drop below the desired threshold. When the soil is dry, the Arduino via the 5-feed relay module, as I said before, powers the DC pump. The pump then draws water from reservoir and directs it into the plant or soil through tubing. Next, we have 3-volt AA batteries. We use two batteries, and it supplies power to the 5-feed relay module to activate the 5-feed DC water pump. Next, we have 60 times 2 crystal LCD screen. So it can display real-time information such as soil moisture level, system status, pump operation, and other useful messages. It also can display messages like pump on, for example, soil moist on 45% of it, or irrigation off or on. And it will be giving instant feedback about what the system is doing at any moment. That's all for me. Then I'll pass to Amma.
Thank you, Ashwin. The discussion. The IoT Arduino automatic irrigation system project aim to enhance the efficiency of water usage in agriculture by automating the irrigation process based on real time, so moisture reading. Throughout the irrigation of various sensors and components such as the Arduino Uno R3 or R4. So moisture sensor, relay modules, and water pump. The system provides an intelligent solution for managing water resources. The IoT Arduino automated irrigation system demonstrates the potential for technology to optimize water usage in agriculture and small-scale gardening. Overall, the project represents a practical and scalable solution for promoting sustainable agriculture, agriculture and resource efficient farming practices. And the last conclusion, the IoT Arduino automatic irrigation system provide a practical and efficient solution to modern agricultural challenges, particularly in optimizing water use. By leveraging real-time so moisture data and automating the irrigation process, the system reduce water wastage, ensuring that crop or plant receive the right amount of water and at the right time. That's the potential of IoT-based smart system in revolutionizing traditional irrigation practice, improving water efficiency, and promoting sustainable agriculture, which further advancement and scaling. The system contribute to smarter farming practice that address global challenges like water scarcity and resource management.
Okay, thank you, Amma. So that is it for our project presentation. But before we go, I want to show you guys a demo about how our project functions and works. So I will basically explain on how the system works. I will show you guys the setup of our project. So this is the setup that we're going to be using to water your plants or anything. But right now, we can only use Arduino microcontrollers. Maybe in the near future, we can make a custom-made integrated circuit or module, basically a custom-made microprocessor or microcontroller specifically for this type of project. So you guys don't need to buy Arduino. So you guys can make your own circuit board to place it in, and you can just paste it on the wall with a pump or water tank, and that will be easier. So I am going to show you guys all our demo project, the in real life demo. So as you can see, I have the Arduino Rev4 board here. So we connect this to our laptop, and this will be where all our code is. You see, this is all our code. So we will use this code to make the circuit work and function properly. So this is our automatic irrigation system. We have an extra soil module probe here. So this soil module probe here, the one that I'm holding right now, this one will be the receiver or the transmitter to send data to the LCD screen from the Arduino to the LCD screen. So we can get a display here, which you can see is 34%, and the status is now moist. Same with our capacitive soil moisture sensor. But with this sensor, since we are using IoT, I can actually open the. So with this capacitive soil moisture sensor, and with the help of the relay and to the 5DC pump, with the help of the LCD screen to display our data, so we know what our moisture levels are and if the pump is on or off. We have this ESP module right here. So with this, I can actually turn the pump manually on and off. But actually, I don't need to turn the pump manually on and off because our system is a smart irrigation system. So we're mainly using this IoT as a hub for storing our data based on the moisture levels. So we can monitor our moisture levels remotely without needing any sort of other equipment. So we can basically use this to monitor our moisture levels and the status of our soil, the irrigation system, to see if it's running or not, any errors or anything. So we don't really need to use say another physical screen anywhere to see our data. We can just use our phone or our computer or a laptop to monitor our pump and our system for this project. So that's all it. Thank you for listening. All right,
Yep.
so I think that concludes our presentation. Thank you all for lending me your eyes and ears. Thank you all for listening and participating in our presentation. I also thank you to my team members, Ashvin and Ahmad. They really helped me in doing and making this project the way it is right now. I wouldn't have been here without them both. So they really helped me a lot and assisted me in completing this project, and it was very nice job they did. So thank you everybody, and that's all for us. Bye bye.